And we're continuing with section 4.4 on the slope of our lines and coming up with ways to identify that slope value, or what number describes how steep that line is. There we go. Started yesterday, and of course we're going to get down to this last step here today, with just this idea that the slope is a rate of change, right? A comparison between our y values and x values. How much does the y change relative to how much the x changes? And a helpful phrase here to try to help remind you that it's the y's on top and the x is on the bottom. That's what rise over run is supposed to try to encourage you to remember there. Let's see. Good. Another person. Get them in here. And right. And so what we're describing is the change in the y value divided by the change in the x value. If I have a line like yesterday, and I can identify a couple of points on that line from a graph, that's kind of nice because you can see the points and you can see the change. You can count the squares, watch your units, right? Count the squares and then come up with those values, those numbers there. But what we want to take the step to today is, what if we don't have a graph and we just know a couple of points that are on our line? How do we calculate the slope for that line? I'm going to just sort of, you want to say, abstractly label these points. I'll say this is point number 1 and this is point number 2. And so those points now have their x and y coordinates. So I'll therefore call this x sub 1. That's a little subscript. And y sub 1. So this point 1 has x value 1, y value 1. And point 2 over here then has x value 2 and y value 2. Right, not squares, subscripts. So if I'm trying to count the squares or find the change in the x values or the y values, to recall, you know, I could kind of build that little right triangle in there. And I was actually finding the difference, a subtraction problem, right? A difference between those x values. I can say this x value minus that x value told me how big that change was, and a difference in the y values. Say this y value minus that y value, you know, could tell me what that change was. And so that's the basis of our calculation, really, is do that subtraction problem. And it looks like it's a little small. Hopefully, maybe you can figure it out here. So describing, this is, again, I'd say qualitatively, just what are we thinking about? And those first two ideas here. And here's our slope formula. That's what that's called. It's the slope formula. It's that mold, you plug what you know into it and you find the value, the number that comes out. All right. So notice here, if you can see that, maybe I'll just make it real big over here for a second. The difference in the y values, right? I want to take this y value and subtract that y value, right? To find that distance. So I'll call it y2 minus y1. Notice it's both the y's. The y from one point and the y from the other point on top. And similarly, to find my change in the x, I'm finding the difference in the x values for those 2 points. So now what's really important here is if I decide, and I'll to show you it doesn't really matter, if I decide to start with this point, like here for y2, when I do the x's, I have to start with that x also. You know, see how the subscripts are the same here, right? y2, x2, y1, x1. So if I mix them up, I'm going to get basically like the wrong sign, opposite sign for this slope. So this is the formula, blown up, I guess I'd say, that we use. If we know 2 points, I can plug in the x and y coordinates for one and the x and y coordinates for the other and find the difference between those values. Okay, excuse me. So make sure you got that Probably need to learn that one, okay? I'm going to erase this now. I'm going to try to leave that over there on the side. And so we just, for example, right? If I've got 2 points, I'm not even thinking about the graph anymore, right? I've got 2 points. Let's say I got 1, 3 is our coordinates of 1 point, and let's call it, I don't know, just 4, 7, made up something, okay? 2 points out here in the middle, someplace. And just roughly, right? 1, 3, 4, 7, you know. I want to find the slope of that line by calculating it. And I'm going to use my slope formula. So here goes, right? The difference or the change in the y values. It really doesn't matter which one I call 1 and which one I call 0.2. I did this similarly yesterday. The signs work themselves out. So I'm going to call this one, you know, number 2 here, 2 and 1, right? So the y values, make sure you get the y values on top. It's real unfortunate when you get it backwards. 7 minus the 3 will give me the difference in those y values. And now the x values on the bottom, I started here, so I have to start with that x value. 4 minus 1. It's that complicated, right? So my slope turns out to be 4/3. For every 3 I go over, I go up 4. There's the slope of the line between those 2 points. How's it get tricky? Well, you just got to watch out. You know, if you get negative signs in there, we'll run into our minus, minus, right? If I'm subtracting a negative coordinate minus a negative, we're going to see some of that. So just going to do this a few times, okay? Excuse me. And yeah, well, let's just go there. What if I have -3, 4, and what do I have? 2, -1. Yeah, these are all my notes here. Nothing special about these points, I think. So I'm just going to start here. Say the difference in my y's. I'm going to take this y value, 4 minus a -1. All right, watch, there's the minus minus I was talking about already. So difference in the x's, I'm going to start here. Same point I have to start with. -3 minus 2. Okay, now I just do the calculations. 4 minus a negative is 4 plus 1. I got 5 on top. And -3 minus 2 more, -5. Oh, just by chance, it turned out to be a -5/5, and I'd call it -1. Like simplified that fraction, okay? Excuse me. Just, oh, yeah, so let me do it the other way around. I've said this now. What if I did it, started from the other point, right? Okay, what if I did this y first? -1 minus 4. Then I'll start here and do 2 minus -3. So what do I get here? I get -5 on top. Minus minus is plus, so I get +5 on the bottom. I still have negative and positive, just like I did over here. So it's the same. The signs just kind of go opposite, and it always works itself out. Or if it was positive, positive, and I did it the other way around, it'd be negative, negative, which still turns into a positive number. So it totally does not matter which point you choose as number 1 and which one you choose as number 2. Let's see, I might notice what I had. This point was -3, 4. So I was like, you know, over here someplace. And this one was 2, -1. So I was down here someplace, right? It doesn't matter. Just watch your negative signs, right? It could be any place in the plane, those 2 different points. All right. Well, let me just make a couple up and have you do it. I'll wait a minute, right? And let's do 7, -5, and 11, 2. I just made up two numbers, right? 2 points. Can you calculate that slope? Excuse me. You might have done it the other way around, you know, totally fine. We should end up with the same result. What do I get here? -7, and that's plus, that's going to be 18, huh? -7/18. Hope everybody's okay with that calculation. Setting it up is just the issue. Make sure you get it set up in the right order, and then hopefully our subtraction isn't a challenge or an issue right now. Okay? Did you do okay? Any issues, any problems, anybody? Difficulties? All right. And I'm going to purposely, you know, make up a couple lines here, and I'm going to say horizontal line, right? And I'm going to pick 2 points here on that line. What did I do? 1, 2, 3, 4, 5, 6, 7. So -1, 7, and 1, 2, 3, 7. Right? Y equals 7. That's the equation for that line. Y is always 7. What's the slope of that line? Intuitively, maybe we'd expect it to be 0 because it's just horizontal. It's not leaning. Our formula should tell us that. Duh, 7 minus 7. There it is. 3 minus -1. 0/4. There it is. Slope is 0. 0 divided by anything other than 0 is still just a 0. So the calculation confirms what we expect. The slope of a horizontal line is 0. All right. Well, what about that other kind? Vertical. What is that? This one's weird. I'll do something similar here. Here's a vertical line. Make up a couple of points here. And let's say this one is 2, 3, and this one is 2, -2. Okay, I'm gonna do my calculation. Here it goes. M equals, all right, the difference in the y's on top. 3 minus -2. Difference of the x's, 2 minus 2. 5 divided by 0. Can't divide by 0, right? What does it mean? The slope of a vertical line is undefined. It's so steep, we don't know what to call it, you might say. It's undefined. People sometimes say, oh, it's like infinity or something. No, we don't even try and go there. Just say, you can't divide by 0. We call that slope is undefined. So that's one of the special cases you're going to have to remember. Undefined slope, that's a vertical line. And what's my equation for that line? X is always 2. That's what I came up with, what I graphed there. All right. So there, you got to use the formula. Get your y's on top, your x's on the bottom. Do the subtraction and come up with that number. Okay. Well, let's start using that slope. Here's kind of the next thing, or at some point in our homework, What if I know a slope value? And I know one point on that graph, on a line. I know the slope, and I know a starting point. I should be able to graph that line. I can graph that line. I can graph that line. Hopefully you will be able to here in a minute. 1, 4. I'm going to put that starting point on my graph. 1, 2, 3, 4. All right. Now, I need 2 points to connect the dots, right? Draw my line. If I know the slope, this is saying if I go over 3, I go up 2 on my graph. From my starting point, I'm going to go over 3. 1, 2, 3, stop, Steve. And up 2. And now there's a second point. I don't even know the coordinates. I could count them and figure them out. But from a known point, I use the slope value to move to another point. Find a second point. Oops, I missed it. Okay, that's kind of the next step here. I know a slope. If I know a starting point, I can graph it. There's a point and there's a given slope. Graph that line. All right. Ooh, something special about that one. There's a 0 in it. Trying to drum that stuff into you. 0, -2. Oh, that's my y-intercept. Just happens to be the point I gave you as an intercept. Now, it means over 4 and up 3 from that known point. 1, 2, 3, 4, and 1, 2, 3. On the second point. I could count the coordinates for it if I wanted to. Connect the dots. There's my line. Okay? Variations. Keep going here. Negative slope. Same idea though, but we gotta kind of make a decision here. Starting point 1, 2, 3, 4, 0, 4. Again, another y-intercept, and now I want a negative. It's going to be a negative slope. The line's going downhill. Remember that negative value for the fraction is the result of a positive divided by a negative. So you've got to choose to make one of those numbers negative and one of those numbers positive. And it really doesn't matter. And I'll do it both ways. Hopefully that makes sense, right? That's how we get overall negative number is the division positive versus negative. Okay, so this one is telling me that if I go over 3, I'm going down 2. Okay, over 3 and down 2. I'm just trying to graph the line. I'm not trying to come up with any specific point. But from the known one, I'm going to go over 3 and down 2. 1, 2. And I'm going to find that second point right there. And I could connect the dots and draw the line. Well, what if I did it the other way around? This was saying if I go back 3, I go up 2. All right, negative 3x. If I go back 3, I'm going to run into my junk here. 1, 2, 3, but I go up 2. I'm just finding a different point, but it's still on the same line. I did that pretty well. All right, just found a second point. I chose to go this way instead of that way, just by which one of those two pieces I decided to make negative and which one's positive. checking. I think that's kind of the details. That's it for 4.4, which would be a good thing. All right. So, got 2 points, plug them into the formula, find the slope. If you know a slope and one of the points, in fact, gee, let's do one like this, okay? Here's one more. I know 3, 7, and 1, -2. Let's graph, well, that's kind of silly, Steve. I was gonna say, let's find the slope and then graph the line. Well, I know 2 points. So I could just put the 2 points on there and graph it. I was gonna try to go, find the slope and then use one of the points. Not necessary. Ouch. Oh. All right. Yeah. All right. How about 4.5? All right. Using the slope-intercept form. Duh, what does that mean? All right. Here I go. Oh, I did want to, before I go too far, what if I know I have a slope of 2? All right, slope of a whole number, all right? How do I interpret that as rise over run? I need to think of that as a fraction. You got to make it into a fraction yourself, okay? I just needed to point that out, right? It means if I go over 1, I go up 2. You got to be able to see both parts. Okay. So here is an equation for a line in one of those shapes that I've been calling a familiar shape, a familiar form for a linear equation. Pardon me. I've already mentioned this number there, multiplying the x, is the slope value, right? It's the slope value. And in fact, if I write this form, sort of what I call it generically, right? It's that mx plus b, there's the m in the formula for the equation of a line. Well, right now we know that we can build a table of values, plug in some numbers, and plot points and find points to graph this line. Well, in particular, if I put in a 0 for the x, right? If I put in a 0 for x, that means I'm on my y-axis. That's my y-intercept value, right? If I put in a 0 for the x, what do I get for the y value? If I put in 0 for the x, I just get that number out there. That number hanging out at the end, right? 0 for x means that piece just goes away and I'm left with that. That is the y-intercept value, okay? Try to imagine, no matter what equation in this shape I could write up there, if the x is a 0, that piece always goes away. And so whatever that number is added or subtracted there at the end is the y value that goes with 0. That's your y-intercept. Okay, so that leads us to, back to this formula, this mold, you might say. M is the slope, right? B, there's that just letter right there hanging out there, is the y-intercept, y-int, okay? All right, that's the y-intercept value. Now the x is 0, but that's the y value for the y-intercept. That's pretty powerful when it comes to graphing an equation now. I don't need to plug points if I can see it in that form. let's just say, make one I can kind of squeeze up in here. There, all right. Y equals 1/3 x plus 4. Well, it's in that shape, and I see the slope value is 1/3, and the b value is a 4. The y-intercept y value is a 4. Be careful if you're ever asked to write it as an ordered pair, you've got to do the whole thing, okay? 0, 4. Well, I know the y-intercept, I know a point on my graph, 1, 2, 3, 4, and I know the slope. This is just like I did 5 minutes ago, right? Over 3 up 1 gets me a second point, and I can connect the dots. Just by looking at the shape and pulling out the important information from that form, I know the slope and I know a point on the graph. I can use that more efficiently, I would say, or easier than plotting answers, plotting solutions to graph it. Now, because of that information in that shape, I know the slope and the intercept from those numbers. This shape, this form, is called the slope-intercept form. It tells me the slope and the intercept value. Okay. I think so much easier than having to build that table and stick those numbers in, calculate it. Oh, let's just do another one here. How about y equals -3/4 x plus 2? All right. Now, I think some of the mom problems ask you to specifically identify the slope and identify the y-intercept. We're in talking 4.5 now, right? But I'm going to graph this line. Okay. Y-intercept of 2, or 0, 2. All right, negative slope. I'm going to call it -3 over +4. Arbitrary choice, okay? Actually, maybe it'd be better to go backwards. More room over here sometimes. That's why you choose the other way around sometimes. You got more room on your graph over there. But I think I can fit it in. Let's see if I go over 4 from my known point. It's always got to be some starting point, 1, 2, 3, 4, and then down to 3. 1, 2, 3. I find a second point. Use a little mom pencil, connect the dots. Okay. Excuse me. There we go. Y equals 4x minus 3. All right. It's in the right shape, you could say. It's in slope-intercept form. By looking at it, I can see that the slope is 4 over 1. The slope is 4. Okay? And the y-intercept is -3, or 0, -3 is that y-intercept value, is the coordinates. Graph the line. 0, -3, find your starting point. Right, x is the 0. We're on the y-axis. And slope. If I go over 1, I go up 4. Right? 1 positive x, 4 positive y. 1, 2, 3. Right in the middle of mine. Anyway, hopefully you get that, huh? Yep, I'm going to keep going. I kind of have to, I try to talk about the variations, some weird ones you find sometimes. How about this one? Couldn't make it by mind. That just says negative x plus 2. Y equals negative x plus 2. It is in that shape. What's the slope value? Right? Negative, we don't bother to write the 1, right? We don't bother to write a 1 usually. So the slope is negative 1. I'm going to have to call it, positive and negative myself. And the y-intercept is 2 or 0, 2. So, just point that out as an example. You have to assume the number 1 in there. 0, 2 over 1 down 1, right? Over 1 and down 1. Y equals 2/3 x. Where's the rest of it? It's there. There's my slope number. What's the y-intercept? We don't bother to write it if it's a 0, right? And x is 0, now y is 0. Remember this shape, nothing else added, plus or minus, always goes through the origin, right? When x is 0, y will be a 0. So just, again, a variation I want to point out and practice. Over 3 up to, or up to over 3, however you want to count it, over 3 up to, there's the second point.
So I have a quick question.
Yeah.
I'm just like a bit confused on how to find like the first point. I see here that it's just like the
starting point here.
Yeah, but on the last problem we did, it wasn't at like the 0 point. So I was just
okay. Now, before I started 4.5, at the end of 4.4, I did some where I said, what if you're told a point and you know the slope? So here somebody just told you that point. There was no way to, we weren't looking for it or finding it in an equation anywhere. You were just told, here's a starting point, and then from that starting point, use the slope. So that was a little different than what we're doing right now.
Yeah, and that totally makes a lot of sense. I understood that very clearly.
Okay. Now we're using this form of the equation, and what I started out with, and I know how things don't always sink in the first time, was saying, well, what if I put in a 0 for the x? Then the y value is always b. The y-intercept, see, that number out there at the end tells us a point. It tells us that's what goes with x is a 0. If x is a 0, then y is b.
Okay, that makes sense.
All right, so that's what I've been trying to practice with you right now. Right, here's another one, right? And so what this shape is telling us is, oh, there's that slope number. But that number out there, that's what I get if x is 0, y is -3. That's
okay, so the starting point for this one would be like 0, -3.
Exactly, good.
Okay, cool. And then this, okay, that makes sense. Thank you for clearing that up for me.
Good. Yeah, so all right, I just got this one started, right? 0, -3, 1, 2, 3. So a point on the graph you can start from, and we need that. And now over 2 up 1. Short, but there's the line, huh? How about something that's not quite in that shape? Well, we're going to put it in that shape. And hopefully they won't get too messy for you. All right, so here's one that's in that other shape that we've been talking about. And it's, if I had to plot this one, if I had to graph it, you know, I've often said, well, you might get lucky and these two numbers divide evenly into the 8, which into this number, which makes using zeros easy or convenient. Well, the 3 doesn't divide easily into the 8. So I'm going to rearrange this one and put it in the slope-intercept form. You kind of want to have this handy, right? Know what we're talking about all the time, right? Slope-intercept form. So let's see. I'm going to, just because we usually have the y's over on the left, I'm going to leave the y and I'm going to subtract 3x from both sides, okay? If I do that, with negative 2y's here, I'm going to put the x's in front, subtract the 3x's, and there's still the extra 8 over there. I'm getting close, but it's not quite that shape. I've got this negative 2. So I have to divide everything by negative 2. Every term. And that gets me now y equals negative divided by negative. It's positive 3/2 x. Positive negative is negative 4. So there I just did a little extra work to put it in that form. And now, oh, my slope's 3/2. And b is negative 4. I think Mom just asks you to put in the number several times, just like this. But I always like to emphasize that's that ordered pair, 0, negative 4. So I usually write that. 0, negative 4. 1, 2, 3, 4. And over 2f3. Yeah. And I can graph that line, connect the dots. Okay. Well, folks, we finished up 4.4. I got you started, a really good start on 4.5. And if you'll allow me today, I'm gonna bow out, cut it a little short today, all right? We still have for a Monday scheduled to do more of section 4.5. You look at the homework schedule. So we're basically on schedule, okay? And then a couple days planned for 4.6 where we kind of start going the other way, trying to write the equation if I have the information. Like you can imagine right now, if I know the slope and I know the y-intercept, I could just plug them into this mold and write the equation. That's how we're going to start. I'll just throw that at you real quick. If I know the slope and I know the y-intercept, there's the m number, there's the b number. Y equals 4/5 x plus 2. There's the equation. Of course, they get trickier and stuff, but there's a good start for 4.6 if you're somebody who's trying to work ahead. We need certain information. We always need a slope and a point to write the equation. All right, folks, I'm gonna take it easy. I'll sit and watch golf and grade bigger, hand in homework number 6. I have to get my homework done myself. But otherwise, I think I'll wrap it up today. And you guys have a good weekend. Send questions as always. All right. And we'll carry on Monday. Okay. All right, folks. Thank you.
Thank you.
All right.
Thank you.
See ya. Chat. Oh, somebody's good for you. You guys are chatting to each other. That's great.